Welcome to another Lightblade Learning Lab. Today we're going to do a real task that involves marking of stainless steel. Now, stainless steel can be marked with a proper metal cutting laser, and I have managed to mark stainless steel with one of these lasers as well, but not very successfully and at the risk of damaging the lens. So please don't do raw stainless steel. Let me first of all show you what we're going to try and do. On this piece of metal behind me, which is stainless steel, it's 1800 millimeters tall and it's 600 millimeters wide, which is just about the capacity of this machine. Now, I'm hopeful that I'm going to be able to slide this through the machine because it is a pass-through machine, and I'm going to be able to mark numbers and letters on this grid of slots that we've got here. This is basically a key cabinet that I've designed. Now, the bunches of keys are various sizes. They can be anything from the size of my fist here down to just a simple bunch of keys like mine. You can't have all these keys at the same pitch. So I've designed some special hooks that actually fit into these slots in a solid manner. We pop them in the slot and then you just gently tap them down and they then remain permanently fixed in the slot. I say permanently until you knock them out again. But then what we need to do is to mark this sheet up, as already has happened across the top here, with a laser, a proper metal laser engraver, and you'll see that it's been numbered across the top. So all these slots, just like a spreadsheet, have got a reference to them. So there's A, B, C down the side and numbers across the top. So every bunch of keys can have its own reference. The problem is, these numbers, in this light, you can just about see them. But to be honest, they're not very distinct when they're in a dark cupboard. What I've decided to do is to overwrite these numbers somewhere else with etched solid black numbers and letters. And that's what I'm going to show you today. Now, before we start that process, we need to go through a little bit of theory. Now, there are some fundamental things about the laser beam which, in a way, I've been slightly misleading you about up to now. A laser beam is a parallel beam of, and this is the important thing, sorry, I can't write sideways, and all the light is travelling in one direction and it runs completely parallel. It's what they call a coherent monochromatic light. It is a light beam, but it's invisible. I've been referring to it up to now as a beam of heat. That's where I've been misleading you, because it isn't really a beam of heat. It is a beam of light. And it's only when that light hits a surface and gets absorbed into the surface that it turns from one energy form to another. So it turns from light energy to heat energy when it gets absorbed by a surface. If you can understand that simple principle, it will give you a much clearer understanding of how and why the laser beam works. When our infrared beam hits a suitable reflective material, and most metals are a reflective material to some degree. There are some metals which are extremely reflective, things like silver, gold, aluminium, copper. There are other metals, such as this piece of metal that I have here, which is a piece of stainless steel, which is about probably 90 to 95% reflective. So when we fire this beam at any organic material, such as wood, leather, card, any of those sorts of materials, what happens is the surface of the material absorbs the energy, and therefore it starts to heat up, and if you heat it up enough, it will burn. And that is the process by which cutting takes place with organic materials. Now, with acrylic, the absorption into the surface creates heat, but immediately the material evaporates. It doesn't burn. If you fire it into water, water absorbs the energy within the first probably less than a millimetre, and it heats the surface of the water up so much that it boils and creates steam. Now, you've seen me demonstrating that probably in some of my earlier videos. So all I'm doing is trying to reinforce the fact that this beam is totally innocuous until it gets absorbed by an absorbing surface. So when we looked at creating marks on our piece of stainless steel, we were doing damage to the surface of the stainless steel. So stainless steel melts at about 1450 degrees C. We're going to need a lot of heat to cause damage to the surface of our stainless steel. And we're not going to get that out of a 60-watt parallel beam like this. Well, two things are going to work in our favour. First of all, the light in this beam is not uniformly distributed across it. We've talked about it before, and we've said that the energy distribution in this beam is what they call Gaussian. In other words, it looks something like this, where the centre of the beam is very intense light, and the light dissipates towards zero as we get further towards the edge of the beam. Here I've got a lovely little magic pen, and it's a great demonstrator of that principle. If we look at that light there, you'll see that it is very intense in the middle, and it gets weaker and weaker as it goes to the edge. Well, that's exactly what this beam of light is doing as well. It is not a uniform puddle of energy. When I've tried to measure with a thermocouple the temperature in the middle of this beam here, I know that it is more than 1300 degrees C because I've melted the thermocouple, and that is in the standard raw beam, as I call it. But what we would then do is pass this beam through a lens where it would come down to a very, very small area, something that we've previously called the spot size. 2-inch lens has got a spot size of about 0.1 of a millimetre. This concentration of the light becomes greatly amplified, and we get very, very high temperatures now at this spot of light because the energy density has been increased tremendously. So now we can do damage to the surface of stainless steel. But of course, remember what I said to you, stainless steel is in fact reflective. So whatever you fire at the stainless steel, most of it will be firing back at your lens. And this time it will be at a very high temperature, a very high energy density, because it's firing off of a flat surface. And so consequently what will happen is it'll come back up here, and it's likely to damage the surface of your lens. Now, if I shine my light on that lens there, you can see that little black spot there. Well, look, I've removed the coating from the surface of the lens by doing just that, reflecting the beam back onto the lens surface. And so that lens has now been completely destroyed. So if I can't mark the metal surface by firing the laser at it, as we do in most products, you know, we just fire the laser at it and it etches the surface. Well, we can't do that with metal because of this reflective property. So what we've got to do is adopt a different procedure. And the procedure that has normally been adopted is to buy some expensive chemicals. This is a product called Surmark. This one's called a metal marking material, and this one is glass marking material. And you can normally only get this stuff in the States. If you try and buy it in the UK, it's even more expensive because it has to be transported under very special conditions, and those transport conditions hike the price up even more. So from being maybe £10 or £12 in the States, it may be as much as £50 or £60 to buy that same bottle of material here in the UK. Now, how does this material work? Well, basically you paint it onto the surface of your steel, your stainless steel in particular, and then you fire your laser beam at it as though you were engraving normally. Now, although you've got a very thin layer of this material sitting on the surface of your stainless steel, this material will absorb all the energy and convert it into heat. And so this material is the thing that heats up, and in heating up it transmits some of its heat, quite a lot of its heat, into the surface of the stainless steel underneath. And the combination of heating this material on top surface and the stainless steel beneath causes a bonding action between some of this material and the stainless steel. that's basically the principle that we're going to be using today to mark this stainless steel. Instead of this little bottle of material, which would have cost me £60 in the UK, I'm going to be using some of this spray, which cost me about £10 or £12. Now, these two materials are not really the same material, but there is sufficient of this material in this product that it's probably the active material that we can use this dry film molybdenum disulfide lubricant to actually perform almost the same task. If we get the combination of speed and power correct, we shall get a very good black bond on this surface. Okay, now like any normal spray paint, you have to make sure this stuff is thoroughly mixed before you spray it. And then what we need to do is just spray the surface fairly liberally. Quite a reasonably thick coating, as you can see. And we'll just get rid of the excess. And now, because I'm very impatient, I shall use my hot air gun. Now, it doesn't need to be rock hard, it just needs to be dry. We've now got a nice matte grey surface. And that is the surface, very thin surface, that will more or less 100% absorb the energy from the laser beam. I've set this up to the correct focal distance. I've got a 2-inch lens in there, and I'm going to run this initially at about 100 millimeters a second, but I've got maximum power coming through the lens. And what we've got to try and do is to develop enough heat in a single spot to produce this chemical bond. If we run too fast, we shan't get enough heat into a single spot to produce that bond. So I may well have to slow it down if I don't succeed in the first pass. I'm going to close the lid down because this stuff produces some rather strange smelling fumes, and I'm not sure what they are. So I want to make sure that I will extract them safely into my Purex unit. Now, for this first attempt, I've just done outline letters so that we can see the relative density of the letters themselves. Okay, now for the second test, I've rearranged the program. So I've got a small amount of air assist on there so that it doesn't come up and damage the lens. The fumes don't come up and damage the lens. And you can see 100 millimeters a second is actually quite a leisurely speed. We've got our letters that have been hopefully chemically bonded into the surface of the stainless steel. The next process is a bit like magic painting. We need some of this stuff, acetone. And today I'm wearing my protective PVC gloves. And we'll just go for a final clean up. And there we go, you can see how nice and crisp and clean those letters are. And now, well, what I want to show you is this. Yeah, I've scratched the surface, but I've not taken the letters off. Those letters are chemically bonded into that surface. Okay, so I've scratched the surface, but I haven't erased the letter, and it produces nice, crisp, black letters. That was just a test. Now, before I start on this rather large, wide sheet of material, I've got some slightly narrower sheets here that are probably only about 300 millimeters wide. Requires the same type of lettering, different numbers, but I'm going to do this easy one first, because if I make a mistake on here, I can turn it over and I can use the other side, because this sheet is not yet bent. When it's bent, there'll be a front and a back, but at the moment both sides are exactly the same. So I have 2 shots at getting this job correct. To be honest, I'm very confident I should do it in one, but there is an escape road that makes me more comfortable. Now, it's all very well me showing you what I'm going to do and how I'm going to get these numbers and letters into exactly the right place against the slots in both planes. Well, obviously I'm not going to do it all in one go because there's no way that I can make the unit pass through the machine. But what I'm going to do now is we'll go back to RDWorks and I'll show you how I program these numbers. This is how I've imported my sets of numbers. As you can see, I've got 2 sets of numbers here. Well, we don't need both those sets of numbers. And I've also shown you the slots that I've imported as well. So what the first thing I'll do, we're going to do, let's just say we're going to do 21 to 29 to start with. I will delete that set there and we'll work on this set here. Now the first thing I need to do is make sure I know where I'm going to put my head to start with. The important thing for me to do is to accurately position these numbers relative to my slots. And the way that I plan to do that is to mess around with this green dot. So we'll go into Config and System Setting. And here we'll change the position of the green dot, which is the start point for the head, to the bottom center. Close. Now watch what happens to the green dot now. It goes down to there. But look what happens when I remove the slots. So that basically means the head is sitting at the top of the center slot. And that's where I've got to locate the head to get my letters into the correct position. And the reason why I've drawn a rectangle around the letters like that, so that I can put that particular feature onto a different layer. And let's put it onto a blue layer. And on this blue layer up here, we'll set is output no. In other words, I don't want that rectangle to print, but I do want the green square on the center of that rectangle for location. And so now what we've got to do is go to the black letters, which is the parameters up here. Is output yes, speed 100, is blowing yes, scan and max power. That's all we need. So now I shall output that to a memory stick. And now we can be a little bit clever, save ourselves some time by pressing Ctrl and Z several times. And there we go, we're back to our original. So now we can delete this one. And we can delete these. We can call that a blue layer. And it should already contain the properties that we want. Just check. Output no. That's all we need to worry about. All the rest is unimportant. Okay, and we've got our position in the center. And now we'll just check the black parameters. 100, output yes, blowing yes, scan yes, maximum power. Okay. Now we can save that to an output file. Back to the machine. Okay, well I've set myself up the easy one to do with, which is a set of numbers right across the middle of the sheet. But that means I've got to hang one end right out of the machine, and to support it, to stop it drooping, I've had to use one of my tripods. Now what I've also done is set the table so that it's completely level with this and I can pass right through the machine. So I've removed the plate on the back so that this material can pass through the machine. Okay, now if you remember, the idea was to line the head up with the top of this slot. So we'll do that now because that's where we've got to set the origin point. What I've also done is I've made sure that my sheet is running square to the edge of the machine. We'll set that to 5.5. I've got air assist on. We don't want too much air because we're not trying to cool the surface down. We basically want to keep as much heat in the job as we can. Extraction on, and we're ready to go. Right, now you may think we're going to do these letters individually, but as you can see, I've copied a slot with a letter beside it. Now I don't need the slot, other than I'm going to use the slot as a means of setting up this rectangle, and the rectangle will then be where I start from. In other words, I shall start putting my letter from the top of a slot. So to do that, what I shall need to do is, first of all, where should we start? We could start at the end, S, and work our way up the sheet. Yeah, let's do that. So I shall remove those slots, and I shall remove those. Then I come up here to config, system setting, and I'll change my location for the head now to top right. Okay, so that's where my head will start, on a slot. And then I shall basically engrave 4 letters in one program. So the first thing we've got to do, if you remember, is to get rid of the, we don't get rid of it, we need it there, so we change it onto a different layer, and then we'll make that blue layer, if it's probably still there, is output no. That's okay, that's good. And then P, well, if we look at the black letters, we should find the black layer is still set. Output, yes. Engraving at 100mm a second. Is it blowing? Yes. Scanning? Yes. Maximum power? Fine. And we'll have an interval of 0.15. So we can save that to a U file. Control Z. And we've got everything back again. We can delete that. Hold down the Shift key and delete those. And at the same time, we can delete those slots. Delete. We've already got our little green square at the top right hand corner. All we've got to do is to mark the outside shape, put it onto a blue layer, and hopefully the job is done. Okay, let's go and do those. And here we are with the program working. 4 letters at a time. So it's not too tedious. You've just got to keep loading the program. Okay, well now I'm stumped, because here we've got a 600 wide sheet on a 600 wide machine, which I thought was a 600mm pass-through machine. It turns out not to be the case. The aperture at the back is 600, over 600. The bridge is only 560, and there are pillars in the way that hold up the back plane that limit you to something around about 500. So in reality this is only a 500 pass-through machine. So the maximum you can get is 560 if you were to take the pillars out. That basically means I can't engrave the letters down the side. The best that I can do is to engrave the letters at the top and turn my program round and run them upside down from the bottom, and just run with 2 sets of numbers. Well, we are managing to do the letters across the top, and I've now turned the sheet round and we're doing the bottom row of numbers upside down, as you can see. So yeah, we've 20% done the second part of the job. There's a central row of numbers that are missing, and all the letters down the side, but hey, I'm sure we'll make do without them, because we've got adjacent doors with the numbers on and the letters on as well. Well, it's sad that we couldn't complete the job, because as you can see behind me here, this stuff does a very good job of producing black letters, very durable black letters, on stainless steel without any fear of damaging your machine. Well, thanks for your attention. I hope that's been of some interest to you, a practical demonstration of something that's real and not just an experiment. And I'll see you in the next session, so bye for now.